then we will get started. So again, today we are going to talk about using area models to show multiplication. Not last week, but the week before, we used area models, but we actually used algebra tiles underneath the horizontal bar and the vertical bar, right? And the goal was to take algebra tiles and fill in underneath so it is a complete rectangle. And then using the dimensions of the rectangle is what helps us figure out the simplified version of the polynomial. In this case, we're going to talk about the same idea of area models, but we're not going to use algebra tiles today. We're just going to use algebraic expressions to help us figure that out, okay? So I'm going to move to slide 2 here. That shows the steps for using an area model. So step number 1, we're going to draw a rectangle. It's not going to be fancy. It doesn't have to be like super huge. It just has to be big enough for you to write algebraic expressions on the inside. Then step 2, you're going to write expressions on the outside of the rectangle, and that's going to be the same as what we did with the algebra tiles, where we wrote the expression on the top and then also over here on the outside. Step number 3, you're going to multiply each part and write the product in the area below. So you're going to treat it like it's a times table and fill in the area below. Then you're going to simplify or combine like terms, and then you're going to write your simplified answer. So I will give you a couple moments to get the steps written down on your paper, and then we'll go over some examples. If you popped on a little later or just getting on now, we're just doing our notes for lesson 12, which is all about using the area model for simplifying algebraic expressions. All right, again, step number 1 is going to be to draw that rectangle. Step number 2 is going to be to write the expressions on the outside of the rectangle, just like we did with the algebra tiles. Step 3, you're going to multiply each part and write it in the area below, kind of like a times table from when you were little, and then you're going to simplify and combine any like terms, and then you're going to write that simplified algebraic expression. So that's our first example. I'm going to give you a moment to get that copied down on your paper, and then we will, I'll walk you through those examples. Oh, I sure can, Kenzie. I'm sorry. There you go. Let me know when you're ready, please, Kenzie. Thank you. All right, so if we go back to, now let's look at this first example as I was saying. So take a moment to draw what you see on the screen, and then we will walk through the steps for doing this. All right, so we've got that. We're going to use the area model to show the multiplication for 2 times the quantity of x plus 3. And like I said, you're going to draw your rectangle. Notice I've got 2 parts set up for that rectangle because I need a 1 by 2 rectangle, depending on how many terms that we have in those expressions. So then we're just going to, like I said, we're going to multiply like we typically do. So I'm going to do 2 times x, which is 2x. And I'm going to do 2 times 3. And since it's a positive 3, I'm just going to put a positive 6 here. And then once you've done that, then you ask yourself, do I have any like terms in this rectangle for us to combine and put together? And the answer is no. So then you're just going to write it as an algebraic expression as 2x plus 6. If we had been using the algebra tiles, we would have put an x tile here and an x tile here so that there were 2 of them stacked, and then we'd have 6 of those little squares on the inside of that one. So in this case, we're just using the algebraic expressions to go in those spaces. Pretty straightforward, I think. I think you're going to like this model in terms of getting this done. All right, let's look at our second example. All right, so I've got these 2 binomials. These are 2 terms expressions, right? So I've got x plus 4 and x plus 3. Again, because I have 2 terms in each, I need a rectangle that is 2 squares tall and 2 squares wide. That's why we have the 4 parts for it. So once you have that drawn, then we are going to use what we know, like I said in the last one, like we would do a times table. So we're going to fill in each of those rectangles as we go. I know x times x is x squared. I know x times negative 3 is negative 3x. I know x times 4 is 4x. And I know 4 times negative 3 is negative 12. So once you get those spaces on the inside all figured out, find the area of each of those rectangles, then you go back and ask yourself, are there any like terms underneath that I can simplify? Well, in this case, the answer is yes. I've got 4x and negative 3x. So then you just have to ask yourself, if I do 4 plus negative 3, what does that give us? 4 plus negative 3, what does that give us? Thank you. So we know that because we have 4x and negative 3x, this part in the middle is just going to simplify to 1x. So then I also notice that I don't have any other x squareds and I don't have any other plain numbers, constants. So then I would write my final solution as x squared plus, you can put the 1 in front of it. I'm just going to put an x, and then minus 12. And then the big thing to remember to double check is to make sure there aren't any like terms left with the parts that you have. And then because there aren't, then that would be your final answer. So again, draw the rectangle for the spaces that you need, find the area of each spot, simplify your terms, write your final expression. All right, last example. So we're going to show the product of x plus 5 times the quantity of x squared plus 4x minus 2. So again, go ahead and copy what you see on the screen. And here you see that we have 6 squares. That's because we've got a binomial, 2 terms, and a trinomial, 3 terms. So again, take a moment to copy that one down and then we'll work through it. All right, so like we did with the previous one, we're just going to find the area of each section and we're going to write that underneath in each spot. So I know x times x squared, we learned earlier that you simply add those exponents. So this turns into x to the third. I'm just going to choose to go across. You could fill them in going down if you'd like. X times 4x is 4x squared. And x times negative 2 is negative 2x. Then the second row, I'm going to do the same thing. I've got 5 times x squared, 5 times 4x, and 5 times negative 2. The 20 right here in the middle one. Fix that. Then after you find the area of each space, like we've talked about, then you look for like terms. In this case, they're on the diagonals, and it totally depends on what different parts you have. But I've got 5x squared and 4x squared. And then I also have 20x and negative 2x. So I've got to simplify those. But I also see that I've got x to the third. There aren't any other x to the thirds. And I've got negative 10. So let's see, 20x minus 2x. This is going to simplify to 18x. And then 5x squared plus 4x squared, this is going to simplify to 9x squared. So then I'm going to use these simplified terms. It's a terrible 18. I'm going to use these simplified terms then to write our final answer. So again, anytime you write polynomials, you try and write it in what's called decreasing order. Oops. That should be x to the third. Decreasing as far as those exponents goes. Oh, there you go. Let me just make it better. All right, x to the third. We said 5x squared and 4x squared is 9x squared. 20x and minus 2x are positive 18x. And then we've got that negative 10. So what I would suggest as you are doing the assignment here in a few minutes is that you take that opportunity to make sure that you are circling up or grouping those like terms just to help make sure that you are paying attention to those little fine details so that you don't miss out on some of those terms in there that can be simplified even further. And then it's always a good idea to come back down here and just check this line to make sure there isn't anything else that you can combine. But even though that those first 3 terms all have an x, they're not like terms because the exponents are different. Okay? Everybody got what you need from the first example? All right, so here's your closure for today. After you multiply each of the parts of the expressions, what's the next step to ensure that you have the most simplified answer? After you do the multiplication, what's the most important part? Write that down on your paper. Then when you are ready to go back into Schoology. If the white folder is not in Schoology, click refresh on your screen. Whoops, I forgot to change that. It's the lesson 12 worksheet. Complete the problems like we did in today's lesson. So draw that rectangle, show the parts underneath, and then post a picture of your completed assignment on your DUR. And then make sure that you rate yourself. And then take a look at your DUR and make sure if there's anything else that's missing or needs to be completed, make sure that you do that, or even double check my work to make sure that I have taken care of any missings or incompletes for you. Okay, so it's 10:33. The rest of the class time is going to be for you to work on that lesson 12 worksheet, and you'll see it in Schoology. So go ahead and open that folder up